Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter hyperbolic functions, lecture number 4, in which I will solve some problems on hyperbolic functions. Now I will solve some problems on hyperbolic functions. Problem is, separate the following expressions into their real and imaginary parts. Number 1, sin x plus iy. Number 2, cos x plus iy. Number 3, tan x plus iy. Number 4, sin hx plus iy, means hyperbolic sine x plus iy, where x and y are real numbers. Now we solve these problems. Before solving these problems, I would like to give you some basic idea. If x and y are real numbers, then e to the power x and e to the power minus x will be real number, and e to the power x minus e to the power minus x by 2 equal to sin hx, and e to the power x plus e to the power minus x by 2 equal to cos hx will be also real numbers. That means if x and y are real numbers, then hyperbolic sine x and hyperbolic cosine x will be also real numbers. Now we solve these problems one by one. Number 1, sin x plus iy equal to sin a plus b, means sin a into cos b plus cos a into sin b. So here in place of a we have x, in place of b we have iy. Sin x cos iy plus cos x sin iy. This is equal to sin x cos iy is hyperbolic cos hy plus cos x sin iy is I sin hyperbolic y. That means this is equal to sin x cos hy plus I cos x sin hy. Here cos hy and sin hy are real numbers, since y is a real number. So this is of the form a plus ib form. Real part a equal to sin x cos hy, imaginary part b equal to cos x sin hy. Number 2, cos x plus iy. Cos a plus b is cos a into cos b minus sin a into sin b. So here we write cos x cos iy minus sin x sin iy. This is equal to cos x cos iy is cos hy minus sin x sin iy is I sin hy, and this will be equal to cos x cos hy minus I sin x sin hy. This is a minus ib form. Therefore a equal to cos x cos hy, b equal to sin x sin hy. Since y be real number, therefore hyperbolic cosine y and hyperbolic sine y are real numbers. This is the real number and b is also real number. Here we have I. So cos x plus iy is separated into real and imaginary parts. Number 3, tan x plus iy. This is equal to sin x plus iy by cos x plus iy. This is equal to sin x plus iy by cos x plus iy multiplying numerator and denominator by cos x minus iy. And also we multiply numerator and denominator by 2. So here we get 2 sin a into cos b, means sin a plus b x plus iy plus x minus iy plus sin a minus b x plus iy minus x plus iy by 2 cos a into cos b. This is cos a plus b x plus iy plus x minus iy plus cos a minus b x plus iy minus x plus iy, and this will be equal to sin 2x plus sin I 2y by cos 2x plus cos I 2y, and implies that tan x plus iy equal to sin 2x plus sin I 2y is I sin hyperbolic 2y by cos 2x plus cos hyperbolic 2y. Cos hyperbolic 2y and sine hyperbolic 2y are real numbers, since y is a real number. So we separate this in real and imaginary parts. Sine 2x by cos 2x plus cos hyperbolic 2y plus I sine hyperbolic 2y by cos 2x plus cos hyperbolic 2y. This is of the form A plus IB form. A be the real part and this is the imaginary part. So 10x plus iy is separated into real and imaginary parts. Number 4, sine hyperbolic x plus iy. This is equal to minus I sine I x plus iy. Since sine hyperbolic x equal to minus I sine ix, and this will be equal to minus I here sine ix plus I square y. This is equal to minus I sine ix minus I square means minus 1. This is equal to minus I sine A minus B is sine A into cos B minus cos A into sine B. This is equal to minus I sine ix cos y minus minus plus I cos ix sine y, and minus I sine ix is sine hyperbolic x cos y plus I cos ix is cos hyperbolic x sine y, and this is of the form A plus IB form. So sine hyperbolic x plus iy is separated into real and imaginary parts. Here it is true that when x is a real number, then sine hx will be real number. Similarly, cos hx will be real numbers. Now we solve the next problem. Next problem is separate the following expression into real and imaginary parts. Problem is log sine theta plus I phi. Firstly we write sine theta plus I phi equal to sine theta cos I phi plus cos theta sine I phi, and this will be equal to sine theta cos I phi is cos hyperbolic phi plus cos theta sine I phi equal to I sine hyperbolic phi. This is equal to sine theta cos hyperbolic phi plus I cos theta sine hyperbolic phi. This is equal to alpha plus I beta. Let where alpha equal to sine theta cos hyperbolic phi and beta equal to cos theta into sine hyperbolic phi. Since log alpha plus I beta equal to half log alpha square plus beta square plus I tan inverse beta by alpha implies that log sine theta cos hyperbolic phi plus I cos theta into sine hyperbolic phi equal to half log alpha is this, so this is sine square theta cos hyperbolic square phi plus cos square theta sine hyperbolic square phi plus I tan inverse beta is cos theta sine hyperbolic phi by alpha is sine theta cos hyperbolic phi. This is equal to half log sine square theta cos square hyperbolic phi is 1 plus sine hyperbolic square phi plus cos square theta is 1 minus sine square theta sine hyperbolic square phi plus tan inverse. Here cos theta by sine theta is cot theta and sine hyperbolic phi by cos hyperbolic phi is tan hyperbolic phi, and this will be equal to half log sine square theta plus sine square theta sine hyperbolic square phi sine hyperbolic square phi, this is plus minus sine square theta sine hyperbolic square phi plus tan inverse cot theta tan hyperbolic phi. This is sine square theta, sine this and this cancel, and this will be equal to half log sine square theta plus sine hyperbolic square phi plus tan inverse cot theta tan hyperbolic phi. Here we have I, so here will be I, here will be I, and here also will be I. Let this is number 1, This is number 2. This is number 3. From 1, 2 and 3 we get log sine theta plus I phi equal to, right side will be half log sine square theta plus sine h square phi plus I tan inverse cot theta tan hyperbolic phi, and this is the real part and this is imaginary part. This is A plus IB form.